Alright, so I'm so late in making this video. A lot has been happening in the technology world, so it's easy to become sidetracked. However, let's get right into the video. So, introduction to AI, introduction to building AI models. So what is artificial intelligence? AI is a simulation of human intelligence by machines that learn from data to make decisions, solve problems, and adapt over time. So to begin understanding AI, we first need to learn Python, the language that gives machines the instructions they need to think, learn, and carry out other human characteristics. Introduction to Python programming now. So what is Python though? Python is a high-level interpreter programming language known for its readability and versatility. It's widely used in web development, data analysis, AI, and a lot more. So this is actually the icon that represents Python. As you can see, it's like two snakes working together to achieve one goal. So it's basically the ease of use of Python along with its functionality working together to carry out or give instructions to the AI models. Many companies actually use Python though, so from Netflix to Amazon to Spotify to Google and even NASA. So we need to know also about the types of languages, or rather knowledge. So declarative versus imperative knowledge. Declarative knowledge describes what the outcome should be, while imperative knowledge describes how to achieve the outcome. Python is seen as an imperative language, as it actually describes how the outcome should be achieved. One of the most useful functions of Python is its use of the arithmetic operations. All right, let me just give you show you right here what we can use them for. So we have the basic addition, subtraction, multiplication, division, and yeah, let me just bring up the terminal, show you how these work. Well, they're basically self-explanatory. Alright, so the terminal. So addition, 1 plus 1, that gives you 2. You can even, let's say 2 plus 2 times 7 divided by 909 times whatever that number is, and the answer gives you that number, 0.0. Alright, so variables and data types now. So variables, containers for storing data values. So variables are like containers, like a basket that stores fruits. Variables are actually what stores data values. Now these values being stored can be separated into types. So we call them data types. You have integers, which are whole numbers. We have floats, decimal numbers, strings, which you can see in the quotation. These can be any character, but as long as you put them in these quotes, they're seen as a string. We also have booleans, can be one of two values, true or false. We'll learn more about those as we proceed. So control flow, let's talk about if statements. So execute code based on conditions. Now this is a small block of code. It has an if statement. We need to know about if statements also. So what this is saying, if not is instance a int, print a is not an integer. Now let's break this down. So it's basically saying it takes two arguments, a and int. So it's saying if a is not an instance of an integer or a whole number, we're going to go ahead and print a is not an integer. Else we just print a is an integer. Now let's put this into code so you can have a better understanding of what I'm actually saying. So let's switch to the interpreter. Alright. Alright, so switching to the interpreter, let's write this code. Alright, so if not is instance a, comma int, we have to put our colon, it's like sort of like the full stop for Python, or rather, it shows the ending of the, well, if state, well, the if call. So we move into the actual function. We ask it to print, based on the condition above, we print in string a is not an integer, else we're gonna print a is an integer. So it's pretty straightforward what this will do. However, to ensure that you have a good understanding, let's just run this. Yeah, we have to save the code. All right. So we have to actually give a value to a. So assign it a value. Let's say 7. Yeah. So remember, we're asking if a is equal. Well, a being equal to 7 if that's an integer. Right. So I'm gonna go ahead and switch the tabs to the terminal where you guys can see the results. A is an integer. Now let's change a to an actual string, then ask if that's an integer, just to make sure that it works. Let's change it to the string happy. Yeah, let's change a to the string happy. Run this. Ask if it's an integer, if a is an integer. Now let's see what the terminal does. A is not an integer. So yeah, that's basically what that function actually does. That gives you the general idea of how if statements work. Now we move on to control flow or loops. Two types of loops, for loops and while loops. For loops iterate over a sequence, while loops execute as long as the condition is true. So while loops will keep going, never gets tired as long as a certain condition is true. Let's look into for loops though. So this code right here, for I in range 5, print I. As it sounds, pretty self-explanatory. For every single I in range 5, you're gonna print whatever that I is. The tricky thing is, Python doesn't start counting from 1. It starts counting from 0. And whenever you see range, it counts up until the digit before whatever digit is given as an argument. So you see 5, it counts from 0 up to 4. So for I in range 5, print I, it should print 0 to 4. Let's just write this out in the actual interpreter and see what's printed in the terminal. Oh, also we can use a hashtag to actually write comments. Comments are lines of codes that are totally ignored by Python. This is how you just make your notes. So control flow. Then we move on to writing the actual code. For loop. So for I in range 5, we are gonna go ahead and just print whatever I is. So let's run this code and take it to the terminal to see what's printed out. So there you go, 0, 1, 2, 3, 4, and it's still printing our first function where we had querying whether or not a is an integer. All right, so let's move on to functions. Defining functions rather. So in the Python, you can actually define your function, have it, well, what this allows or what this accommodates is the reusability of that function. So if it is that you define a function somewhere in the code and you want to use the functionalities elsewhere, you just need to call the name and the functionalities can be used wherever you call the actual function. Now the structure of this, you have def for define, then you have the name of the function, greet, and it takes argument name, then you end it with a colon, don't forget your colon. Now moving into the actual function itself, we're asking it to print hello and whatever name was given as an argument. This f right here this is what allows for the name to be printed along with the string hello. So this F is for the formatting. It takes whatever name is given here and places it right here. So you'll have hello, whatever name should be printed. All right, so let's write this in the terminal just to ensure that you understand what I'm saying. So bring the terminal up. Also, we spoke about comments earlier where we use the hashtag for Python to ignore whatever line of code is. We can actually use the comment blocks of codes. To do this, what we use is the quotation. So triple quotation, triple quotation, and Python ignores all of this. If you're ready to use it, you can remove those and your code is ready to use. We just do this to avoid the system or idle continuously running or the entirety of our code over and over. We just want to run what we're currently testing. So yeah, defining functions. So define the name of the function is greet. It takes argument name. Don't forget your colon. Now we're asking it to print f, string. Need our quotation to show it's a string, hello, comma, name. Alright, so what this should do is print whatever name you give here as an argument. It should say hello and whatever name is placed right there. Let's run this to make sure it runs and compiles. Seems well. Now let's move over to the actual terminal. Yeah, so the name of our function is greet. Let's give it a name as an argument. Let's give the name Jill. So hello Jill. And that's how functions actually work. Yeah. Alright, so moving on to lists and tuples. Very, very important. So two types: mutable sequences and you have immutable sequences. Mutable allows for change. It's like having a fruit basket and with apples, bananas, and cherries. You can always swap out the bananas for oranges if you like oranges. You can swap the cherries for grapes. That's mutable, allows for change. Immutable sequences now, those don't allow for individual change. So example, we have coordinates being equal to 10 and 20. If it is that you want to change the 10, there's no way you can just change the 10. You have to just get rid of the entire tuple, 10 and 20, and place totally different values there. Unlike mutable, as mentioned, you can change the banana, put in orange, and I'll show you what I'm talking about. Alright, so mutable sequences. We can actually write code within the terminal also, but I would suggest not, rather not. It's best to save it in the actual interpreter. But yeah, proceeding with our mutable sequences, let's have our fruit basket, fruits being equal to square brackets. Inside our basket, let's place apple. Love apples. Bananas. We've got to have bananas. Banana. Yeah. Okay. So cherries. And why not some berries also? Well, grapes. Equal. So what that does is it saves the actual fruit basket. So when you ask it for fruits, hey, what's inside fruits? It tells you apples, bananas, cherries, and grapes. Now, let's say you no longer like apples for whatever reason. What you can do is fruits, square brackets, you can call wherever the apple is, or better yet, the position. Remember we said list, or rather Python starts counting from 0. So apple is position 0, banana position 1, cherries position 2, and grapes position 3, though there are 4 items within the basket. So apple being position 0, place 0 should be equal to, let's give it, replace apples, replace apples with some berries, because why not? Now we ask it what's inside the fruits basket. You got berries, bananas, cherries, and grapes. No more apples. Alright, so moving on to a simple calculator. Remember our variables actually take the value of whatever is on the right side or right hand side of the equal sign. So the equal sign rather in Python just assigns data to variables. So our variable num1 is equal to an integer, but that integer, it comes from an input. Now, an input that you will be providing, that's what input does. Input takes input from the human and assigns it to num1. That way we can reuse it. So this though prints the string. The first thing you'll see, enter first number. You will see the string printed. You'll enter your number and that number will be assigned to num1. The same thing happens with num2. Enter second number, assigned to num2. Now, what's happening here? We're asking for Python is asking to print sum. This string right here, this word will be printed with a colon, comma, whatever is in num1 plus whatever is in num2. Simple calculator. Now let's just build this out. As simple as it is, let's build this out so you can better understand how this works. So take me to the interpreter. Alright, so I've commented out our code because we're no longer testing those. So num1 is equal to whatever integer is given, input, which you'll be asked for here, string, enter first number, colon, make it more elegant. Num2 now, num2 is equal to integer, input, enter second number, and now we ask it to print. So go ahead and print the word sum, results, sum, or we can say sum is equal to comma whatever num1 is plus num2. Alright, so we've got our num1, num2, print whatever the addition of those are, the result for that is. So let's run this code. Alright, let's take you to the terminal to see what's happening there. There you go. Enter your first number. Let's write a bunch of 9s because why not? That seems like enough 9s. Another number, 7. Enter. And that's your sum. A simple calculator. Alright, so that actually is all we're going to be covering for today. Thinking of actually making this a weekly thing. For now though, you guys are definitely going to need to install 2 applications at least, or Python and VS Code. Installing VS Code, you should receive you should also install the extension Python within VS Code. But links are provided in the description. You can check those, click on those links, download and install these software for future videos.